Apa yang kemarin ini?
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the International Virtual Course on Fundamentals and Technology of Advanced Materials Lecture, Session 8. We hope that all the speakers, committee, and participants are in a good state of physical, mental, and social health as well. Before we begin the lecture session, let us pray together according to our respective beliefs and religions. Let us begin. And finish. Ladies and gentlemen, first we would like to take Zoom online photos with our lecturer. So please open
Recording
your
in
cameras.
progress.
Okay. Okay, we would like to take Zoom online photos. So please open your camera. Then we are ready to take the Zoom photo. Please give your best smile. I will count. 1, 2, and 3. Okay, for page 2. 1, 2, and 3. Okay, thank you. We request all of you to please stand by and keep your camera open and microphone muted. Dear participants, today's lecture session will be given by Dr. Engineering Muhammad Syafrudin from Sejong University, South Korea. The topic of today's lecture is Artificial Intelligence for Battery. During the lecture session, if you have any question, you can ask the lecturer directly by using the raise hand feature, or you can write your question in the meeting chat, and then the moderator will read the question. Let us start the lecture session. Please, Dr. Engineering Muhammad Syafrudin, you can have your time.
Okay, all right. Good afternoon, everyone. Morning and good night. Thank you very much, Ms. Camila, for the introduction. So, please let me share my presentation. Right. Is the screen is visible?
Yes.
All right. All right. Again, thank you very much for having me. It was my pleasure, and it was an honor to be invited for this fundamental technology of advanced material for the international virtual course in this year. So, as introduced by Ms. Camila, so we are going to learn together related topic with introduction to AI, artificial intelligence, for a better. So actually, my background or my department is actually Department of AI and Data Science. So pardon me if I couldn't explain the material science in correct way. So and if I made some mistake, then you can directly correct me. So today agenda, we are not going to teach you, but we are going to share what we have learned. And personally, I'm also interested in this battery, and I'm also maybe in the future going to research in this direction for applying AI and data science for a better battery. So let me just quickly introduce myself. So I was having my bachelor degree in Indonesia. So actually, my background is informatics, is engineering field, and I took my master and PhD degree in industrial and system engineering. And my research field is actually application of AI in manufacturing. And after my graduation in 2019, I joined assistant professor in the same university that I took my master and PhD for 3 years. And then after that, I moved to my current university in 2022 in AI and data science department. And mostly we are working in industrial artificial intelligence, and we haven't actually applied this battery in our field, but we have some plan in the future, so that maybe if the listeners or lecturers, professor from ITB or from other university are interested in the collaboration, then we might have a chat after this lecture, after this session. And yeah, if you are going to connect me, I'm already open to LinkedIn, or you can send me any email, and then I can try my best to reply your email as soon as possible. So without further ado, today agenda, we are going to have a brief introduction into battery, and we are going to introduce what is AI, and if we are going to work in AI project, what we have to step by step. And after that, we are going to learn what are the current state of AI and machine learning application to battery. Basically, there are a lot of application already exist, and many researchers, professor already apply this AI and machine learning into battery, and we can try to follow them, and we can try to find the gap that are currently missing, and we can fill those gaps for our future. And lastly, we will have some concluding remarks. What will be the takeaway for this session? So for the introduction, as we know that we are currently living in the global warming. So mostly every year we have CO2 gas that are transmitted into our ozone or our atmosphere, and it generates a lot of heat, which is increasing the temperatures. As we know that myself in Korea, usually in summer it's not very hot, but it's become really hot because every year the temperatures increase. For example, last year it was only maybe 35, but now it can be 37 or almost 40. So it is very urgent for us to introduce renewable energy, including utilizing battery. As we know that when we use battery, then we are going to use electricity, and by using electricity, then we are minimizing emitting or minimizing transmitting CO2 into our ozone or into our atmosphere. And it is very urgent for us to deploy energy transition, as I mentioned earlier, by utilizing some nuclear or renewable energy. And one of the batteries that are currently being used in production or in the commercial way is a lithium-ion battery. So please correct me if this is wrong, because actually I'm new in this lithium-ion battery field or in this material science. And as my literature, I put some reference here. This LIB or lithium-ion battery is actually start from 1991. I think I was 1 year old after this year. So it was very old technology, but these days they are advancing this technology and being used in massively or in production. And there are many organizations that are currently working for the sustainable or including this battery. So there are many tools or protocols as well as the funding that we can apply to support our research in this direction. And yeah, the global battery demand is expected to increase. As we know that, especially in Korea, we do have many electric vehicles or EV, and they are using battery. And we do have some bus that are also using electricity or EV bus, so they're using battery. So the demand itself, it's projected to be increasing. It will be increased not only 25%, maybe more than that one, as many countries are adopting this battery or EV vehicles. So the key rule of the battery is basically decarbonizing transport or electrification of vehicles. And it also included in the renewable energy field because we are supporting the shift from fossil fuels with electricity. By doing so, then, as we mentioned earlier, we are going to minimize CO2 transmission into our atmosphere. And using the battery itself also can help us to spread out or burden up the energy access, because maybe in the remote area they do not have direct electricity, so we can store this electricity into battery and we can transmit those, or we can maybe transport those battery into the remote area. And battery also could significantly reduce the emission, as I mentioned earlier, and this will account for 40% of global emission. So I think reducing 40% is very much, so that it can help us to at least prevent the global warming to getting worse. And this global battery has, of course, the market itself or the customer. We have a lot of countries that are adopting. And from these figures, we can see that most of the demand itself is based on the application as well as based on the region. And as you can see here, the China are having a lot of demand for this. I think because they are very eager to develop EV vehicles as well as to produce their own battery. So they try to invest many resources in this field. And for the by application, as we know, we have a lot of EV vehicles, including cars or bus, etc. So in the future, we hope that the fossil fuels will be replaced using this battery electric vehicle or EV. Now, what is the connection between battery and AI and machine learning? As we know that in the battery field, when we are going to propose or when we are going to produce a new battery, then we do need to do some experiment. And in the experiment, as my short understanding, we need to go in the lab and we need to do some manual work. I think we can combine several chemistry, what is called chemistry molecules or something like that. And by doing so, then we are going to evaluate whether this battery is better than previous version of battery. So this kind of process will consume a lot of time because we need to invest for the human and we need also to invest for the material that will be used. But if we can, for example, digitalize this kind of material, and then we can let the computers to do the simulation, or we can let the computer to find the best combination between several composition of battery, then it will shorten the time and it will also decrease the cost. By doing so, then we can also increase, or you can also find the best battery composition with best efficiency and best performance in the short time. And directly we can also produce this kind of battery in massive or in huge quota or in huge size. So in the battery itself, we do have some complex challenge, right? Because we have a multivariate problem, not a single one. Because battery has many variables, not only the molecule or the component itself. Maybe there are many environments, etc., that we have to consider. And AI or machine learning itself have some potential, as I mentioned earlier, by letting the computer inside to do the manual work that are currently being done by human resources or some resources in the lab. But of course, this have some challenge because as we know that AI are currently being used in many fields, but as a in production or as a research, there is some challenge. The first challenge will be the data, because AI is basically data intensive. So if we can provide good data for the AI, then the AI can produce good. And the second thing will be the algorithms, or you might say the function, or you can say it. Yeah, the method, right? The method that we can use to produce good result. It should be well crafted or well designed so that we can have a good result for our battery R&D. Now let's move on to the AI itself. What is AI, so that we can have the same understanding. So please pardon me if this introduction to AI is very general, and if you have already understand, hopefully this will give you some recall for your understanding. So actually AI is a general field, and inside the AI there is machine learning, the methodology that apply AI itself in the AI general term. And more specifically, we do have a deep learning. So deep learning is basically the method that are specialized or specified for specific application. And we call something machine learning when instead of telling the computer to do something, we let the computer to come up with some idea or some output. So we just give the data to the computer, and of course we have to define the algorithm, as I mentioned, the method that we learn from this data, and later on it will produce whatever we want. For example, if we want to produce some groups, for example, we have a bunch of data of, for example, material for the battery, then if we apply this into method using machine learning, then machine learning can group based on, for example, the similarity of this molecule or this material. They can be grouped automatically because basically this method can do it according the design that we have crafted before. So instead of telling the computer to do A, B, C, then we can just let the computer to learn from the data. And this is the intuition that I mentioned earlier. So actually AI, machine learning, and deep learning is similar like a baby. So actually baby learning from experience. For example, we learn how to walk from the experience, so step by step. And the machine also learn from this experience. And this experience for the machine learning is basically a data. So if we can provide a bunch of data that good for the machine learning, then eventually this machine learning will produce good results. So machine learning involves allowing machine to learn from the data so that the computer program can change when exposed to new data. For example, if as I mentioned earlier about the grouping the material of battery, then we let the machine to group based on the similarity. For example, the similarity may be based on the structures or based on the type, or I'm not quite sure what will be the material in the battery. I mean, how many material that currently exist in. And yeah, machine learning field itself is actually interdisciplinary. So for example, AI or machine learning expert might not have good understanding about the battery in basic way or in advanced or in expert way. So we can collaborate with the battery expert and AI expert to come up with a good program or good model for battery. So it's come from data, and after the data, then we do need some domain knowledge. So I think if we are going to deal with the battery, then we have to have battery expert to have some domain knowledge, prior knowledge, so that we can gather or we can collect good data, and after that, we can generate some insight, and from the insight, we can do some action. So machine learning is basically a combination between computer science, statistics, mathematics, and if we are going to apply this field machine learning into battery, then we can add maybe a battery expert or material science expert. So we use the data to answer questions. So if we go back to example that I mentioned earlier regarding finding new composition of battery with new molecules or new materials. So in this case, we do have some question, right? The question is, what is the best material for new battery? So that's the question. From those questions, then we are going to collect, for example, from the previous work or from the papers that are already published, what kind of material that has been used. And using those material, then we can collect those data. And then later on, when we have a bunch of data from the previous papers, then we can fed or we can use this a bunch of data for the machine learning algorithm to learn or to generate, for example, to find the possibility or find some combination, new combination that are not being used or that are not being produced before. So those kind of things can be done using AI, machine learning, as well as deep learning. So basically, critical thinking combined with a technical tool will help us in this field. And why machine learning? You might already know that we do have some issue related with big data. So big data means we have a bunch of data, not only in the social media. As we know, maybe some of us are being online every day, like utilizing social media or utilizing email, etc. Then actually we are generating a lot of it. And in battery field or in other fields that are currently working with the data, then they also produce a lot of data, so that using this a lot of data, our machine learning or deep learning or AI model can better learn from experience from the. And machine learning is very powerful. As you know, it's already applied in our everyday life. If you use social media, then might have auto tagging photo. For example, if we upload our photo into social media, and those social media will directly suggest us that this person is might be this your friend name. Then you can directly tag this. And for the movie recommendation, for example, if you watch online using some Netflix or some other movie platform, then you might have some recommendation based on your historical data. Because, for example, if you just watch movie A, then later on you might receive a similar movie based on that you have watched it. And yeah, machine learning has been used in any application, such as maybe you might heard about ChatGPT or generative AI, that you can produce a bunch of facts freely, or you can answer any question that you have. Even it can analyze the text or figures, or even generate the video like using deep fake or something. And in terms of in battery, we can use this AI machine learning model to, as I mentioned in the beginning, also to find new material that can produce better performance, for example, or better to produce more efficient battery, etc. Or even it can also help us to maintain the performance of battery. For example, it can predict the remaining usable life, if I'm not mistaken, RUR, right? Or maybe SOH, or state of health. Right? So we can measure the state of health of this battery, because measuring the state of health of battery is very important because as you know that there are many cases that the EV or sorry the lithium battery are explode without any reason because maybe there's some heat inside the battery and we couldn't predict or we couldn't monitor the state of health of this battery. So if we can monitor this state of health of battery, then we can prevent this kind of cases to be happening. For example, if we can detect before this battery explode, then we can detect the state of health or SOH. Then if we find any anomaly or we find any abnormal situation, like for example, this battery might be explode in maybe 1 hour or something, then can do some preventive action before that happen before this battery is. Yeah, of course, there are many applications that we will mention later. The conclusion is basically machine learning help us answer the question. So whatever answer we have, as I mentioned, whether we will want to find new material for new battery, or we want to predict the state of health of battery, or maybe we are going to do anything that we might have question, then we can try to apply this machine learning to answer our question. Yeah, here is the general flow. Of course, there are many guidance that we can follow, but I hope this is the simple way. So first, we do need to have some question. So from having question, then we can look for the data that we have. If we do not have the data, then we can produce this data in the lab, or we can use some simulation. Or if we can find existing data on the internet, I mean from the previous researchers, then we can use this previous data, and then by understanding this previous data, then we can revise our question, or if the question can be answered, then we can directly apply machine learning or AI algorithm to our data. And the next step will be exploratory data analysis. This is just to check whether our data can be used to answer the question. And after that, we can just let the machine learning algorithm to do their job to answer the question. And of course, we have to evaluate whether our model that we have provided or we have crafted or we have designed is performing really well using performance. And for, as I mentioned, the research question and data exploratory can be processed many times. For example, by checking the data, then we can fine tune our question, or by referring to the question, then we can fine tune our exploratory data analysis. And yeah, this is some question or project that I have. So for example, by having some research question, and then we can answer the second step whether we have the data or no to answer the question. And if we do not have the data, then we can generate our data, or we can find the existing data that are currently available from previous research. And if the data is labeled, we are going to explain later on. This is in machine learning. When we are having the data that has label, which is have an output, it's called supervised. While if we do not have an output, just the data, it is called unsupervised. We are going to explain again later. So let's start by answering why do we want to build the AI model. So machine learning will allow us to tackle or to help us answer some question that we do not need to directly give the instruction. So we just allow this machine, or we just allow the computers to learn from data that we provide. So it will help us avoid the need for human to specify all the knowledge to the computer. What we have to do is basically provide the good data, and the machine learning algorithm will do that job. And again, this is just some human intuition. So human are learning from experience. So actually experience is data, while the machine is learning from the data, a bunch of experience that we can provide for them. So machine learning will learn or extract some pattern based on the data that they provided, and later on they can be used to predict the futures, or they can be used to group the similar data that we. Here is the inside the modeling part. We do have some tasks. What is the problem we want to solve? Whether we have data has label or no, and then algorithms in the machine learning. We do have many method or methodology or algorithm, we might say, depending on the task that we have. If our task is supervised, we have a label, then we might use different algorithm, different method. And if our task is unsupervised, then we will choose another algorithms. And lastly is performance evaluation. This performance evaluation also related with the task that we have. If it is supervised or unsupervised, then we do have a different performance evaluation. Yeah, inside the task, we can define our model, and we can select some attributes that can help improve the performance of our model. And yeah, here is some methodology how well our model performs. It can be more technical, so we need to improve the performance of our model and decrease the error of our model. And yeah, some of the performance evaluation might have not specific here, but depending on the task that we have, we do have many available performance metrics. I think including in material science, maybe in material science, they have a different metric to evaluate whether they can, whether the produce, maybe the produce combination of material are better than previous, then can have different performance. And here is what we mentioned earlier. In the machine learning algorithm or model itself, we have a supervised. So we have a data that has label. For example, the easy way is image. For example, we have an image of cat and dog. So we have an image cat, then we have label called cat or output cat. So given image cat and label cat, or image dog and label dog, then we have a bunch of cat and dog image, and we just need to fit this cat and dog image with the label into machine learning model. Then later on, machine learning model will learn what is the pattern that correspond to cat and what is the pattern that correspond to the dog. And later on, when we have this model and we have a new data, what we have to do is just pass this data into the model, and the model will analyze whether this image is cat or dog. And maybe if we think of the battery or material science, as I mentioned, maybe you can have a list of material that already being used to produce the battery, right? And the output might be the performance of, or the label, the output may be the performance. For example, the performance can be label, maybe high, normal, or medium, or numbers, depending on our. And the second thing is unsupervised. We just have a data and we do not have a label. And if we refer to the image cat and dog, we can provide just image and then let the machine learning do their job, maybe finding some similarity from this image, and eventually they will find some pattern and group this image into group A and B. And by using the human expert, it can be judged whether the group A is cat or group B is dog, for example, like that. And in the material science or in the battery field, then you have a bunch of maybe material for the battery, and then let the machine learning group based on the similarity. For example, I'm not sure what will be the similarity in the molecules, or maybe the similarity of the structures, or some other material that are similar to each other. And yeah, here is overall working principle approach. On the left side, if you can see, we have a data, and when we are going to evaluate our model, usually we split our data into training and testing. So the training is used for learning, find some patterns, and for the testing is to evaluate the performance. So if the performance of our AI machine model is good both in the training and testing, then we can conclude that our model, our AI machine model, good. And here on the right side for the result, we can see that there are two types, classification and regression. The difference between those two is basically for the classification, it produces the class. Or for example, if we say cat and dog, we have a label cat and dog, then it will give us the label whether this is cat and dog. While for the regression is basically fitting the model into the line, and this will produce some numbers, or might say numeric. Instead of giving the label, this will produce some numbers. For example, if you have a bunch of combination in material, then the output for this regression will be maybe the voltage or maybe the efficiency, and it will be numbers for the regression. So depending on your problem, if you want to use this machine learning, deep learning, or AI model for classification or classifying or giving the label, then you can perform classification. While if you want to have the numbers as output, then we'll perform regression. Depending on these two, then we will use a different AI machine learning model. And in the literature, specifically in Petri, I think these four machine learning algorithms are being used. First is neural network, okay, and B is decision tree, and C is support vector machine, and D is k-nearest network. Neural network is basically an algorithm that has been used very old, many years ago, and idea for this neural network is basically we are going to mimic how the human brain works, because in our brain we do have some connection, or you might say neurons, and between neurons there is some connection, or it's called synapses, I think, if I'm not mistaken. So this neuron will be connected with the line, and each of the
Dear sorry, it seems like there is technical problems, but please wait until Dr. Syafrudin come back to this Zoom.
hello, I'm sorry, I think my connection was lost a moment ago. Okay, let me turn off the video. I think I have slow connection at the moment.
Okay, sir.
All right. So I think it was in this slide about the neural net. So yeah, basically, let me repeat again. So neural network is trying to mimic how the human brain works. So we do have some neurons, in the layers, the input and hidden layers as well as output. And the common neural network architectures that we are currently being used is artificial neural network. That is the basic one. And if we move further to the advanced version of this NN, it's called convolutional neural networks or CNNs. And this is basically a deep learning algorithm, and it's currently being used for image recognition as well as for time data analysis. And the second thing is decision tree. So decision tree, random forest, boosting, and baking is basically one family. Different is that decision tree is a tree, single tree.
I'm sorry, sir.
Yes.
Syafrudin, I think your share screen is gone. Maybe you can share screen again.
Okay, sorry. Let me check again. Let me. Second, I think. Okay. Yeah. All right. So is the screen visible?
It's visible.
Right. Yeah. Okay. Okay. Apologies for the technical issue. I think here we have some connection. Okay. Then the decision tree, the second algorithm that is used in battery and other bits too, is decision tree. And decision tree, we have many versions called random forest and boosting and baking. So decision tree is basically a tree, as the name it says, and it is actually if and else logic. So it simplifies complex problems by breaking them to smaller subproblems. For example, if x1 is less than c4, then if it is true, then it will go to the left or go to the right branch. It's kind of tree. You have many branches. While for the random forest, as the name says, inside the random forest, we do have multiple decision trees. Like forest, like we have many trees, so this is also similar. For random forest, basically, we are incorporating many trees so that the result from the individual will represent the general or the final output or the final label that we are going to use. While for the boosting and pegging, similar with random forest, but it will lead to more reliable package. And the third will be support vector machine. So the support vector machine is basically try to find the best hyperlink. So as you can see in the C figure here, we have a straight line in the middle, black one, and each of the dot is basically the label or the group that we are going to separate. For example, if the if the yellow one is a picture of cat, and then the green one is a picture of dog, then we are going to find the best line that can separate these two types, two labels. This is support vectors. Of course, there are many variants that we can find from the literatures, but this is to just introduce you that SVM is being used to find this line so that we can have a minimal error being produced by dividing this line between two groups. And lastly is K nearest neighbor or KNN. And this is a simple yet effective method for classification and regression that group data point based on proximity, based on the distance, the nearest proximity. And it can predict the output of new data by comparing it to the closest k neighbors with the optimal number of k. For example, if we set the number of k is being 3, then we are in the neighborhood, we will count how many points we have. For example, if the point we have is 3 or more than 3, then it will be grouped as new group or new label. So this is very simple based on the similarity. And now, after understanding that battery is very important, as well as we learn about basic understanding of AI and how we can work on AI project or how we can perform AI project. Then now let's study what have previous researchers already done by applying AI for battery. The first is application to material design and synthesis. So previous researchers has applied in the middle here, as you can see, SVM, support vector machine, and neural net and decision tree for classification as well as regression. I might not be able to explain what is the target properties and material, but hopefully maybe later on, if we can share this PPT, we can learn that there are many material that we can design, or we can find the better design, or maybe we can synthesize using the help of AI or machine learning model. And here's, I think, from researchers from Korea, published in the scientific report Natures. They design the schematic representation of procedures to establish optimal synthesis parameters for the, I think, Ni is nickel rich NMC cathode material. So as you can see here that they follow the similar pattern, right? So they have a bunch of data. They have a bunch of data, and using the data, they train. Here we do have some brains icon. They train the model, machine learning model, and then using the trained model, they want to predict. Numbers. As you can see here, there is a graph with R square. They want to predict some output numbers, and by using that predict output number, they want to evaluate whether the performance of our model that they use are performing better or not, and they use the data based on the experiment. And other researchers also use many data, and they compare between DFT. If I'm not mistaken, DFT is density functional theory, and they compare whether the performance of DFT are similar or maybe the performance of machine learning are similar or better than DFT. And they found that the performance of machine learning are slightly better, or in some point they are equal with the DFT method. And we can also use this AI or machine learning model to help us to construct the combination between, I think, the molecules in this. One of my student in my graduate course topic in machine learning, one student from material science, he present this topic, and using machine learning, in this case neural network, they can find the best molecule combination. Of course, they have data of molecules, and then they try to combine, or maybe they try to do some simulation using AI model, so that AI can find the best combination between molecules, and eventually it will give us maybe generate us the best energy potential using this combination of molecules. And the second application will be, I think, electrodes and cell manufacturing. And previous work has used similar machine learning model, SVM, super vector machine, decision tree, neural net, as well as other things. And as you can see on the left, we have a target properties, and on the right side, we have a material that are being used for this case. And in producing the LIB or lithium ion battery, there are many processes that have to be done. Like, I think from the left figure, we can see that for each of the process being used, there is some cost, right? There is some cost and challenge. And this cost and challenge might be able to be solved by incorporating machine learning, AI, or deep learning algorithm so that we can have a better performance battery as well as we can have a cheaper, maybe and then more efficient or more safe battery. And this is more technical also. From the literatures, I took this picture from the literatures. So in the production or in the manufacturing, when we are going to produce a battery based on data-driven, what does data-driven means that we produce something and we collect the data. And by the collecting the data, then we are going to apply this machine learning or AI model so that AI model can help us optimize the process. For example, we can optimize the temperatures, or we can optimize, for example, we can optimize or we can speed up the process, or we can, we can have more efficiency in the production line. So I think this is more technical. Shouldn't study. And here is, I think, this is more technical also related with data-driven cell manufacturing or battery manufacturing. So, for example, if we are going to develop the data warehouse for the manufacturing, then we can try to incorporate AI or machine learning to help us to predict the maximum capacity of our battery. What will be the maximum for each of the cell that are being produced in our manufacturing. And in this figure, one of the researchers tried to combine between experiment in the lab, I mean web experiments, if I'm not mistaken, using some material in the lab, and they want to combine with the simulation in modeling. So by combining these two input and then fit into the machine learning, they hope that the performance of their AI machine learning model perform better than only utilizing single data. And it will find out that their performance is better than using single model. So the takeaway from this figure is that if we can think of data not only from single source, then it will help us to increase the performance of our AI or machine learning model. Because having single model or having more than one is better than having single data source for the AI model. And for the next application of AI, we check. You can see the title. Material and electrode architectures characterization. And here from this application that I understand is basically utilizing some of the image using X-ray or using 3D image to find the electrode and some characteristics. And in the literature, there are new algorithm here that have been learned from our previous slide. It's called convolutional neural network. This is a deep learning algorithm. And we do have generative adversarial network. So this is a deep learning algorithm that is being used to produce new data. It's called generative. So if you have used ChatGPT, actually ChatGPT is belong to generative artificial network field, that they can produce new text or new image based on their data set. It's called generative. And in the literature, some researchers try to apply CNN, convolutional neural network, to determine crystal space group from high resolution image, atomic image, and diffraction profile using hierarchical classification with CNN model. And by doing so, they can have an input as an image into our model, AI or machine model, and then the output will be class, or the output will be regression numbers, depending on our. And here is, I think, for the GAN, they want to use existing, for example, the main challenge in AI or machine learning project is basically the data itself. I'm not quite sure in the material science, is it easy or is it challenging to generate the data? So if it is challenging, then what you have to do is you can have a small data set, and then utilizing GAN, then you can generate similar data set, or you might increase the number of data, and this data will be produced based on your small data set. It's called generative artificial intelligence, to generate or to increase the number of data, so that you can fit this artificial generated data into your AI or machine learning. And this study found that GAN can be used to address missing weights problem in electron tomography. I think this is image. And comparing between the data, original one with the generated one, they found that TomoGAN, they say that their model is TomoGAN for the tomography image, effectively denoise the image. For example, when you have a noisy data, then utilizing GAN, then you can denoise or remove some noise and just keep the non-noise data or clear data. And lastly, I think this is semantic segmentation. As the name it says, in AI or machine learning, we can actually segment image in any image, including in material. For example, if you can capture the material structure into the image and you want to point out the structure, for example, what will be the white color, what will be the red color, what will be the green color, that can be done using machine learning or AI algorithm. So AI and machine learning are very powerful. It can be applied in anything. And as you can see here, I think the study also use X-ray tomography data, and using CNN or convolutional network, they can accurately track and quantify morphological change in material with high efficiency. I think if human need to do it manually, then it will take a lot of time. And then now let's just feed this image or feed this data into AI model, and let the AI model find or track the change or track the image. There's some high performance or some high efficiency. And in this case, I think another researchers in material science also use 3D electrode microstructures, and they want to develop similar model that use 2D image, construct 3D microstructures. Both workflow focus on generating accurate 3D electrode representation. And here is another, still they use some image, 2D or 3D, and the objective here is, I think, they want to identify for the particles that prone to cracking, which could exaggerate thermal runaway, especially in smaller particles. So in this case, they have a supervised learning. They have a bunch of image, and this image has a label. For example, whether the image has cracking or normal. And then machine learning will learn from this bunch of label data and found the structures or found some patterns. And after that, you can find new image without label, and this model will give you the label, whether there is some crack or non-crack or normal one. And the study or the research says that they develop supervised machine learning classifier or algorithm that can efficiently and accurately detect breakage-related particle, and this will reduce the need for manual inspection and minimizing effort during model train or during model testing. So AI and machine learning is basically helping us to automate or say help us to remove manual inspection, and this manual can be replaced or can be assisted by the AI or machine learning. And I think this is more detail again about microstructure that I couldn't explain. I'm afraid if I explain it, there might be some mistake. I mean, in the material name, but here, as my understanding in AI, here we do have image, regardless of what image that are being fed or being used by the AI model, it will give us the label that we provide. So if we give the AI model with the image of material and the class will be the material for that image, then the AI will give the same result. And if in my field, as I mentioned, if it is cat and dog, then if the input image is cat, then the AI will produce the label will be cat. And lastly, I think this is the most interesting part is AI for battery cell diagnosis and prognosis. So once we produce the battery, once the battery is being used in the market or in the customer, it is very important for us to have some diagnosis and prognosis. Diagnosis means we are going to know what is the current state of the battery, and the prognosis is to prevent some uh, to to know to prevent some what can say to prevent some unexpected or unexpected or something that we don't want to be happen, such as for example battery will be explode or there will be degraded battery without any notification or without any alert. So there are many algorithms that are being used to do this job. For example, neural net, SVN, as well as ensemble learning. They also incorporate unsupervised learning. And here for the targets, they can predict the remaining useful lifetime for the battery or RUI. And SOH is a state of health. SOC, I think, state of charge. And SOT, state of, I'm not, I just forget that. So SOC and SOH that is being used in the literatures or in the researchers. They try to predict whether the battery will have a remaining useful lifetime as well as the current state of health and state of charge. And these researchers also develop the machine learning algorithm to predict the safety of the battery. And they use 2,600 numerical simulation data to evaluate their performance of their model. And they found that their model can provide accurate performance to classify whether the state of the battery is safe or short circuit or unsafe. So if it is detected as unsafe, then it might be some prognosis or some prevention action should be carried on very quickly so that unexpected situation can be prevented in advance. And the second thing is aging and health prediction. I think health prediction and safety prediction look like similar, but for the aging is how the battery can survive, for example, for the next cycle. For example, usually the battery will degrade it, right? When we use the battery many times, then the performance will be degraded based on the number of the cycle for this battery. So using AI and machine learning algorithm, we can try to predict whether this, based on the previous history of cycle or previous history of discharge capacity, then we can give some insight whether this battery can survive in the next 5 years or 10 years, or maybe in the short run, the next few months. So basically, AI model will help us to give us some informed decision so that you can take appropriate action, whether you want to replace the battery in advance or you're going to maybe check whether there is some error or some of the mistake in the battery, so that we can prevent any unexpected situation in the future. And this is more detailed. So if you are going to develop aging and health prediction, then you can have to collect raw data of battery. Then you can do some data preprocessing, etc. And then you can split the data into training and testing. And you can feed this training data into your AI or machine learning model. And then you can evaluate it using test data or validation. And before we end, there is another application of AI in the battery. It can be used for recycling and second life assessment. So in one, if I'm not mistaken, in one vehicle, they have a large battery, and I think inside the battery they have a smaller battery. So by using AI or machine learning model, we can group whether each of the smaller battery inside the large battery are in the group 1, 2, or 3, or 4. If it is in group 1, then it is in the good performance. And if it is in the group 2, it is in slightly decreased performance. And if it is in the group 3, then it is in the yellow one, maybe slightly warning. And if it is in the group 4, then we need to replace. So AI can help us by analyzing or finding which of the smaller battery inside the big battery should be replaced. And by doing so, then it will help us to increase the speed up the replacing performance, because we don't need to check it manually. The AI or machine model already inform us that this battery need to be replaced in this specific location or in this specific bigger battery storage. And for the second lifetime assessment, this also will help us, right? Just only replacing the battery that need to be replaced, so that we can decrease the dispose of the battery, because I think producing the battery is very time consuming, and it will cost a lot of material and a lot of cost. So if we replace good battery, I mean, if we mistakenly replace good battery, then this good battery will be discarded. But if our AI model can suggest us that group 4 should be replaced, then we just need to replace this group 4 instead of group 1 or group. I think that's for the application of AI machine learning in battery. Now let's have some concluding remarks, and after this we can have some discussion or question. So, of course, there are many challenges that we have to overcome if we are going to do some research AI for the battery. The first is descriptors. So the success of machine learning or AI model will heavily depend on the selecting of the right descriptors. Descriptors mean attributes, or you might say features, or data. So depending on the task that we have, or depending on the field that we are currently working, including the material design characterization, I think you know your fields better than me, and you have to understand what data that you want if you want to apply machine learning to answer your own question. And then the second thing after that, in many fields, including I think maybe in the material side, data scarcity and error determination will be the main issue, because maybe I'm not sure, is it easy for you to get the small data, get the data in your material side? So if it is challenging, then you might come up with small data set. And by using small data set, might be you have a higher error, because you couldn't represent the whole scenario for your own problem. So in this case, maybe you can apply different techniques such as transfer learning or using a GAN, generative artificial network, to generate more data so that your machine learning or AI model can learn from a lot of data, not small data. And I think the third is lack of standard, maybe. You have to check whether there is some standard of data. Maybe the format of data between natural science and my field will be different. And some terminology, some concept might be some different term. You have to check it. And lastly, I think user-friendly tools, because mostly in AI, in my field, we need to do some programming. I'm not quite sure if in natural science there is some existing tool that you can use, like plug and play. Plug and play. For example, you just plug the data and then play with some or choose some machine learning model and get the result. You have to check that case. So if you don't have that one, then you can collaborate with AI expert that can implement the program to some code or some programming language. Then you can collaborate with it. And the third thing, I think, bridging scales, that will be also last or the other challenge. Because in machine learning project, if we have a large data set, then we need to think of large computing power. If we use our own laptop, maybe it will take weeks or maybe months to process the data. So that will be another challenge that we have to think of. And for the futures, the perspective and the current, that we can try to implement big AI, which is current AI system mimic human intelligence, but lack of genuine understanding and consciousness. While for the strong AI, we need to truly think and carefully understanding how AI can be used. And then the last is we have to promote or we have to suggest for the strong collaboration between battery expert and AI expert so that we can have a data-driven approach, and it will accelerating innovation for the battery technology. And in conclusion, we know that AI and machine learning are transforming not only in battery research, but also in our everyday life. So if we are going to apply this AI and machine learning, then we can try to enhance our data analysis as well as optimizing performance and accelerating innovation in this area. And the integration of this technology promises to significantly advance battery development, but of course requires strong collaboration between battery expert and AI expert so that we can combine two expertise or more expertise to give a better solution. So embracing this synergy or collaboration can, of course, lead to breakthroughs, and new generation of battery will be produced in the future, driving progress in energy storage and sustainability. Yeah, I think that's the end of talk. If you do have any question, you can directly ask me, or maybe the moderator can take your question. Thank you very much for your attention. I hope this will be useful for me, myself, and for you. Thank you very much.
Okay, thank you for your insightful presentation, Syafrudin. Does anyone have any question? You can ask the lecturer directly by using the raise hand feature, or you can write your question in the meeting chat and I will read the question. Okay. Maybe for the first question, I will ask. Okay, sure. Machine learning is proving to be critical in this research efficiency. Do you have any recommendation for those new to AI or the machine learning about material physics? Maybe for those who knew about this, where should we start, or how should we start to learning about machine learning? Thank you.
All right. Yeah, I think a very good question from Mr. Kamila. So yeah, that is very great question. The first thing I think you can start from previous work. You can find the papers that specifically work in your field. For example, it was mentioned energy efficiency. Is it correct? Yeah. Then you can search some papers in that field, and you can try to find the paper that are already use AI for that. And then by doing so, then you can understand what data that they use for their purpose, and then try if they share some data or some program that you can try. But for the basic introduction, I think you can learn AI in general, right? So that you can understand if you're going to work in AI, what will be the input and what will be output, and how the process is work. Of course, the detail, it's depending on the field, right? If it is in energy efficiency, I'm not sure what is the data there, but in other field also the data might be different. But the flow or general workflow will be, I think, similar. I hope that answer your question, Ms. Camila.
Yes, thank you so much, sir. Maybe other participants? Does anyone have a question? Okay, this is a question for Fahrisah Durfa. Thank you for your great presentation, sir. My name is Fahrisah, and I am very interested in using machine learning to translate lab image. Page 47. In my thesis research, there is a section related to how two-dimensional image from FIB SEM results can be made into 3D. Can you give your opinion and ideas on how I can use machine learning and try it on my sample? Is there any source to learn specifically about this? Or is there an example of machine learning that can be tested? I am very grateful for that knowledge and explanation.
I think, yeah, Ms. Fahrisa, Anupa, it's very great question directly related with her research, right?
I'm sorry, Mr. Syafrudin, I think your video is freeze and we cannot hear your voice. Okay, it seems there is a internet or network problem with Mr. Syafrudin. So please wait. And we kindly remind you to fulfill the form attendance in the meeting chat. Okay.
Yeah, yeah, I'm sorry. I think the connection was suddenly disconnected.
Okay.
Let me repeat again. Her question was how to transform 2D image into 3D image. So in this
Yeah.
case, if you have a bunch of 2D image, and then you can apply machine learning to map to the 3D. So in this case, you have to have 2D and 3D as output. So if you have a pair of 2D and 3D, then you can try to learn machine learning or build the machine learning to qualify. I'm not quite sure the algorithm specifically for this case, but if you are interested, then you can start searching from the internet that what kind of machine learning algorithm that can deal with the 3D image, or 2D to 3D. how we can use input as 2D and output as 3D. I hope that's answered the question.
Okay. How is Fahri Sah? Has that has enough, or you have the following question? Miss Fahri Sah Nurfa? Okay, maybe does anyone have any question? Okay, maybe there is no question left. So, uh, Ms. Syafrudin, do you have any closing statement to us about this lecture?
Okay. First of all, thank you very much for having me. So hopefully, yeah, this sharing session. Actually, I'm also learning in this field, battery research. So hopefully it will triggers my interest and yours too. And if you do have some question, feel free connect me through LinkedIn online profile, or you can send me email. And I think that's all.
Okay. Thank you very much, sir, for your interesting presentation on artificial intelligence for battery. We are so glad that you could be here today to share your insights, and we hope that all participants could gain many new insight and knowledge from your lecture, of course. And this is the end of today's lecture. We would like to remind all participants to always check the announcement given on Soft Teams. And for the next session will be held on Monday, August 11 at 8 a.m. That's all for this session, and thank you for your participation. Have a nice weekend. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, everyone. Thank you, Ms. Kamila. Thank you.